Hello and welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With 200 gigabit private networking, node balancers, a 40 gigabit public network, fast object storage, and a brand new managed Kubernetes platform, all controlled by a convenient API, you've got everything you need to scale up. And for your tasks that need fast computation, such as training machine learning models or running your CI and CD pipelines, they've got dedicated CPU and GPU instances. Go to pythonpodcast.com/Linode, that's Linode today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. You monitor your website to make sure that you're the first to know when something goes wrong, but what about your data? Tidy Data is the data ops monitoring platform that you've been missing. With real-time alerts for problems in your database, ETL pipelines, or data warehouse, and integrations with Slack, PagerDuty, and custom webhooks, you can fix the errors before they become a problem. Go to pythonpodcast.com/tidydata today and get started for free with no credit card required. Your host as usual is Tobias Macy, and today I'm interviewing Luke Hoban about building and maintaining infrastructure as code with Pulumi. So Luke, can you start by introducing yourself?
Hi, my name is Luke Hoban. I'm the CTO at Pulumi. Previously spent time at Microsoft doing sort of application developer tools and at Amazon doing cloud infrastructure on EC2.
And do you remember how you first got introduced to Python?
Yeah, so I've worked in sort of the programming languages space for a lot of my career, and even back in college and things, kind of got introduced to Python mostly from sort of an academic perspective, just seeing it as sort of another programming language, another interesting space in the spectrum, and just using it from that kind of perspective. I think my next sort of deeper engagement with it was actually working at Microsoft on sort of .NET and worked with a lot of the teams building Iron Python actually at the time. And so really sort of seeing Python through the lens of kind of the Microsoft developer ecosystem, which was sort of an interesting lens to see Python through. And then I think more recently, just personally, got a lot more exposure to Python just as a lens into kind of machine learning and that kind of thing, just learning that from a personal perspective. And then I think with Pulumi was where I've personally really gone the deepest in my career so far with Python, which is really kind of building and designing APIs and programming models for Python developers to program the cloud and work with cloud infrastructure.
And so in terms of the concept of infrastructure as code, can you give your definition of that and some of the ways that it manifests?
Yeah, so I think of infrastructure as code is really about kind of applying sort of software engineering principles that we kind of use in software development. So when we're building our Python server applications or our JavaScript web browser applications, we use a set of sort of software engineering principles. We use code to write these things down. We use source control. We use IDEs to get sort of completion and error checking. We use a whole bunch of different things that are sort of part of being able to scale up the complexity of the software we build to sort of tackle complex problems in our application development. And I think infrastructure as code is really being that same trend, bringing that into the cloud infrastructure space where there's all these amazing building blocks that are available from these cloud providers. But to really take advantage of them, you've got to bring them all together, build complex things on top of them. And to do that and scale up that complexity of what we do with our cloud infrastructure, we really need to bring to bear a lot of those same kinds of tools that we use kind of for application development. And so for me, infrastructure as code is really about doing that, bringing all those tools to bear. And I think, in the industry today, infrastructure as code is sort of largely, I'd say, infrastructure as text. It's sort of taking that very first step of being code and making it something you can write down in a file. You can put it into source control, you can version it in source control. That starts to give you some of these benefits of being able to repeatably deploy a thing and be able to version it and be able to have multiple people contribute to it. But we think there's so much more that you can do when you bring this idea of software engineering into your cloud infrastructure. And so that's kind of what we're focused on with Pulumi.
So can you give a bit more of the background of what Pulumi is and some of the story of how it got started and how you've got to where you are today?
So Pulumi, we sort of think of as a modern infrastructure as code tool. So really taking the ideas of infrastructure as code and taking them to where kind of a modern cloud is today. We see that from a few different perspectives. So one, Pulumi lets you use existing programming languages, not sort of very constrained DSLs like JSON or YAML or HCL, but real programming languages like Python to describe your cloud infrastructure. And as well as doing that and all the sort of software engineering benefits that you can kind of get from that, Pulumi really focuses on sort of some of the modern cloud scenarios. And so things like the ability to work with serverless, the ability to work with containers, the ability to work with Kubernetes. These kind of technologies that organizations are moving increasingly quickly towards as they sort of move into the cloud. And making it really easy to take all the different building block pieces you need in all these domains and bring them together to support the sort of cloud infrastructure that your applications need. There no longer has to be as much of a divide between the way that you do your application development and the way that you do your cloud infrastructure development. These things can now become more integrated, both because you can use Python for both, but also because the same team, the same sort of engineering principles can be used across the two. And in terms of the kind of backstory behind it, I'd say, from my personal perspective, I, as I mentioned, worked on kind of application developer tools, worked at Microsoft for a long time, worked on .NET, worked on Visual Studio, worked on creating the TypeScript project at Microsoft and on some other tooling projects there. And so I've spent a long time kind of building tools that enable application developers to sort of scale up the complexity of what they can build and seeing what that enables developers to do in the JavaScript ecosystem, in the .NET ecosystem, with Windows, etc. And so then, when I moved over to kind of work in the cloud space, I sort of saw that there were all these great building blocks in the cloud providers, but the developers were still really struggling. They had to be very advanced, have a lot of very specialized skill set to figure out how to build the kind of things that people want to build on top of these cloud platforms. And so sort of, I think the story behind Pulumi was really seeing that there was this huge gap, that there was this inevitable shift towards the cloud for a whole bunch of great, productivity and, economic reasons. And yet, developers weren't being empowered to fully take advantage of all that value that was there. And that there was a big opportunity to sort of help with that problem and help with it in a way that we felt like we understood how to sort of bring developer tools and software development practices to this space.
And one of the elements that I want to draw out from there is this idea of empowering developers to be able to manage the infrastructure, where for a while the servers and the infrastructure was the domain of systems administrators, and now it's largely being relegated to the quote-unquote DevOps engineer, where the intent is to try and bring the operational aspects closer to the software development aspects so that you have people working together and collaborating on that. And I'm wondering what your thoughts are on the background and the context and the specific skill set that's necessary for developers to be able to adopt, to be able to effectively design and build out these infrastructures as part of the application lifecycle, and what you see as being the breakdown in responsibilities of developers versus operations engineers for being able to design and manage this infrastructure.
Yeah, I think it's a great framing there, and I think there is there's a couple of big trends that we kind of see generally. I mean, one is of course just more and more cloud adoption, and so more and more usage of these sort of cloud APIs and things. But at the same time, we see kind of two layers on top of that. One is that as folks move into some of these modern cloud technologies, it means that there's sort of more and more cloud resources that they're managing, right? And so it's no longer a few years ago it might have been that you had a handful of VMs. They were managed by some systems administrator, and the development team, either SSH'd in and did their deploy inside there or ran some very simple kind of CI process onto that. But the infrastructure didn't change all that often. You added a new VM or a new database server or whatever, once a year, and you rarely kind of made changes to it. And so it's a very static kind of environment in which your cloud infrastructure worked. And so, the sort of operation of that didn't have to sort of move at the pace of the application development team or the pace of the kind of business itself. And as we've moved towards sort of more modern cloud technologies, I'd say that iteration cycle on infrastructure, the speed at which infrastructure changes has shifted fundamentally towards many layers of this actually iterating at the speed of the application development team. So if you look at technologies like serverless or Kubernetes, for example, a lot of the infrastructure associated with those projects being deployed onto Kubernetes or onto serverless technologies actually has to change nearly as fast as the application code itself. So for serverless, kind of every time you want to deploy your application, you're actually changing resources in AWS. Or for Kubernetes, you have to sort of write specifications of the sort of the environment variables and context in which your containers are going to run and how they're going to be wired up into load balancers and services and things inside Kubernetes. And so we see that more and more that ownership is sort of shifting closer to the application development teams, just from at the speed of iteration and the place at which the affinity is with the sort of ownership of the delivery. is moving so that the application development teams have to have a better understanding of some of these cloud primitives if they want to take advantage of the value of some of these sort of modern cloud technologies. And then the other part of that is just as that complexity rises generally, even within the sort of traditional platform teams or DevOps teams or even sort of traditional infrastructure teams, the amount of cloud infrastructure being managed is just going up dramatically, both because of just the shift into cloud and also because of the shift towards these more modern cloud technologies where there are more moving pieces and more managed services and that sort of thing. And so that complexity leads to the need for more of these software engineering principles. So even those traditional DevOps or sort of systems administrator teams are finding that they need to bring in more sort of software engineering practices and controls into the way that they do their jobs because the complexity is going up there as well. And so both of those trends that, the traditional folks doing this work are finding they need more software engineering tools, and a new class of folks coming into the space from the developer end of the spectrum are kind of coming with a developer and software engineering mindset. We think both of those trends are kind of leading to a need for this kind of tool.
Another element of that dynamic is the fact that infrastructure engineers and platform engineers are generally trying to optimize for stability and the sort of continuous operation of those systems, and developers are trying to optimize for rapid release cycles and rapid change. And sometimes that can come into conflict if the engineers are put in charge of managing the infrastructure because they might not be optimizing for some of the types of controls that the platform engineers are trying to incorporate and enforce. And so I'm wondering how they can work together effectively in this new landscape of managing the infrastructure as a software artifact, and some of the ways that they can enforce some of the things like security policies or infrastructure consistency so that it's easier to manage in the long term.
Yes, that's a really big part of kind of what we focus on actually with Pulumi. And I'd say there's two key ways that we sort of think about that problem, that opportunity really, to empower kind of both of those teams to sort of succeed at the different goals that you just highlighted. And one of them is just the sort of core software engineering idea of being able to build reusable components and abstract away complexity and abstract away best practices and security and compliance things behind reusable components. And so one of the things we see a lot of teams who end up using Pulumi doing is actually taking their platform team will build some of these components that have those best practices built in, have the sort of, the security layout for their networking infrastructure or the IAM policies defined that they want to allow folks to use in different situations within applications. And they'll build those reusable components, build the sort of packages and components that can be used by application development teams to deploy infrastructure into the AWS accounts and into the cloud environments managed by that sort of platform team. And so that ability to create sort of reusable components that abstract away some of those best practices is a really important sort of software engineering tool generally. I mean, that's how we have the software we have today. Like Apple provides great APIs for iOS that don't just give you raw access to the primitives of the device, but they also give you best practices around sort of security and compliance with things in the platform. And so here it's the same thing, and we want to both ourselves provide some of those libraries, but even more important, empower those platform teams to build those best practices into reusable libraries that they can then use to empower their application development teams to use those. And the second part is that using those components is a good thing just to kind of for ease of use for not having to kind of copy paste that compliance criteria all over. But we really want to also enforce some of that and help those platform teams to enforce that anyone who does deploy into this environment must meet all of these compliance criteria. And so Pulumi does also actually a new capability that's coming with Pulumi 2.0, which is launching very soon, is the ability to add policy as code. So not just to describe your raw infrastructure as code, but also to describe policy about your infrastructure using code. And so that would let you say, nothing is allowed to successfully deploy with Pulumi inside my organization or inside these projects within my organization unless it passes all of these checks. And so checks that ports haven't been opened on my security groups, or that certain images or only certain blessed images are allowed to be used inside containers. Any of these sorts of criteria that you have within your organization that platform team wants to enforce, they can then enforce through kind of this policy offering. And so we do see sort of multi-layered approaches to this, but all of it sort of fundamentally empowered by using real code at all these different layers and providing the tools for both that platform team and the kind of ultimate application development team.
And where does the name come from?
Yeah, so it's actually, our founders, Joe and Eric, worked at Microsoft as well for a long time. And they had a colleague there who was one of our early advisors when we started the company. And he unfortunately passed away, actually. But his last name was Broom. And sort of as a tribute to him, the name is Broom in Hawaiian. So Pulumi is Broom in Hawaiian. So sort of a tribute to him, but also a name which sort of stood out. SEO for it is pretty good. So, it kind of caught our eye. So.
And in terms of the overall landscape of infrastructure as code, one of the most notable entrants to that is Terraform, which has grown a fairly large following. And then there are some of the platform-specific tools such as CloudFormation, and there's some measure of capability built into a number of configuration management frameworks. And I'm wondering if you can compare and contrast some of the capabilities of Pulumi and how it fits into that overall ecosystem.
Yeah, so in broad strokes, kind of sit in the same sort of space in the infrastructure as code space as many of these tools. And we're seeing just overall like a ton of growth in that infrastructure as code space, and a lot of folks kind of moving from, managing infrastructure by point and click or by, using an SDK directly to using infrastructure as code. I'd say the biggest kind of difference for Pulumi is, this idea of bringing kind of real programming languages, real software engineering capabilities, and taking that infrastructure as code thing kind of beyond infrastructure as text and towards like a real, software-based discipline. And so that's really the kind of core, technical difference, and it leads to lots and lots and lots of, practical, pragmatic differences that the folks experience when they're using it. Kind of just around, having IDE support and having the ability to debug and having the ability to unit test and having the ability to package and version reusable components and build abstractions on top of those things. And so all of these different, second order benefits you get once you embrace kind of software engineering are really the core things that differentiate the day-to-day experience kind of using something like Pulumi. And sort of think of those as sort of superpowers that Pulumi gives you to go beyond just the raw infrastructure as code, and what are all these things which are going to accelerate and enable your ability to really take advantage of the cloud infrastructure you sit on top of. One thing that is kind of notable, though, is while Pulumi does give you these rich, kind of imperative programming languages, it does still have the same kind of desired state model that many of these other infrastructure as code tools have. So whether it's CloudFormation or ARM or Kubernetes YAML or Terraform, they all have this model that they're sort of a desired state that you specify with your code. And the deployment orchestrator, whichever one of those it is going to help make sure that your infrastructure ends up in that state. So it's going to try and drive from the state it's in to the state you want it to be and figure out the minimal amount of changes it has to make inside the cloud environment to accomplish that. And so Pulumi has that same model. And so it still is sort of declarative in a meaningful sense in the same way that these other infrastructure as code tools that folks may be familiar with are. The key difference just being that you get to use a richer model for how you describe that desired state. And so you can sort of harness some of those software engineering capabilities and harness and tame complexity in front of that declarative model. But you still get all the benefits of sort of desired state declarative models.
In terms of being able to manage this infrastructure and control the complexity of being able to deploy it and enforce the different policies and figure out the different interrelations between all the services that you're trying to leverage, what are some of the common patterns that you've seen as far as being able to address that complexity and some of the challenges that come up because of the nature of infrastructure and some of the fundamental principles that exist in that space?
Yeah, so there's a couple of interesting things here. So one, I'd say, is just the overall complexity of the cloud platforms is pretty impressive. There's just an enormous amount of kind of value in these cloud platforms. And I often think of it like comparing it to other things which folks think of as complex. Like you think of like the browser, for example, as a big API that has a lot of different capabilities and empowers a lot of different very rich experiences that application developers expose. And yet these cloud platforms have probably an order of magnitude more API surface area than the browser does. Just an enormously larger amount of capabilities and properties and APIs that they expose. And they're growing just still at an incredibly fast pace. So, every year at reInvent, AWS announces another couple hundred new capabilities and plus throughout the year, right? And so all these platforms are incredibly rich, incredibly complex APIs that are growing incredibly quickly. And so one of the fundamental challenges is just, hey, how do you even like understand that whole surface area and provide access to it and provide, simpler abstractions over it? And so, So Pulumi does that through just making sure that everything is available in a really canonical way by auto-generating wrappers around the cloud platforms themselves based on the cloud providers' sort of schemas and models for their platforms. But then also making sure that, where there is specific complexity, that we can add these libraries on top that sort of present that complexity in a fundamentally simpler way. And so, for example, we have libraries like we have an AWS X library, which is a part of our crosswalk for AWS, that makes it just easier to work with things like ECS and containers. A lot of folks work trying to kind of use containers on AWS, and it's quite hard when you work with the raw primitives that AWS provides you. It requires 4 or 5 pages of CloudFormation just to sort of bootstrap a basic environment for running a container. And so Pulumi can make that kind of a one-liner, right? By abstracting away a lot of the defaults and complexity in those underlying pieces. And then progressively you can fall back into all of the details and complexity of that as you want. But for the easy things, we can make that easy. And then you can sort of opt into when you want to pick up more and more of the platform's complexity to take advantage of it. But the other sort of side of that is actually the thing that makes this, a fundamentally more challenging problem, I'd say, for infrastructure is just, folks do typically want to tweak a lot of these little settings. And so, compared with if you look at I/O APIs, for example, Python has some really nice, I/O APIs just for working with, the file system, and it's cross-platform. It's pretty rare that folks writing Python code need to reach for a Windows or a Linux or a Mac specific API in terms of working with the file system, even though those file systems are fundamentally fairly different underneath the hood. And yet in cloud infrastructure, we haven't gotten to that point yet where we kind of have any meaningful standardization of cross-platform or lowest common denominator APIs surface area that's broadly used. Folks are still heavily specializing for individual services and individual cloud platforms. And so offering these kind of higher level abstractions is still meaningfully harder than it is, I'd say, for typical Python machine learning frameworks or file system APIs or what have you, where it's become pretty easy to offer nice cross-platform, higher-level generalized APIs. And so that's a key problem that we're working on, is on kind of what are the tools that you need in the infrastructure world to empower you to have these generalized things, but still let folks take advantage of smaller level details when they need to, where they want to really get a specific benefit out of AWS or out of a particular service. And so we have a few tools we've built to kind of help with that.
And one of the common stances of people who are using some of these, as you put it, infrastructure as text tools, is that they are more declarative, and that by using a non-Turing complete language, you can avoid some of the complexities and problems that can arise as a result of the sort of big ball of mud pattern that can arise, or some of the dynamicism that can end up being a foot gun in Python. And I'm wondering what you have found to be some of the potential dangers of using these full programming languages to manage infrastructure, and how Pulumi is working to address those dangers. And then on the converse, what the outsized benefits are of using those full programming languages that would motivate somebody to want to use Pulumi over some of the available tools.
Yeah, so kind of one of my deep beliefs is sort of that we can actually get the best of both worlds here, that we can get sort of all the expressivity of kind of full programming languages, but we can still get the reliability of desired state infrastructure as code. And so I think the way that we do that is by kind of separating the two. The way that we author our infrastructure can be using expressive programming languages and expressive frameworks and components and packages and that sort of thing. But it can ultimately turn into something where that program, what it does is it builds up a model for the desired state. So when I run my Pulumi program, it builds up, here's the desired state I want to be in, and then compares that with the state that we are in, and then figures out what changes it need to make. And because of that, we can still provide things like we can provide a preview. When you go to run your Pulumi deployment, the first thing that Pulumi does is it shows you a preview of what's going to change in your cloud environment. So you can review that. You can say, oh, I didn't expect that thing to change. Let me go make sure that my code is correct. And so we can still get that reliable thing where we can get a preview. We can diff between different states of our infrastructure. As I mentioned earlier, we can run sort of compliance validation on that before we deploy it. So we can do a lot of the things to verify and validate and have confidence in our deployments, really still from that declarative model. And so we don't have to give up the idea that we kind of have a fundamentally declarative approach. It's just that we gain stronger tools for authoring what that declarative approach is. And for me, the thing that I found is, when folks talk about the benefits of it being just a YAML document or a JSON document or something like that is really declarative, and you can just look at it and see exactly what it's going to be. That I totally get the value of that for when you have 10 or 20 resources total. And you can kind of look at it, you can really understand it just by looking at that JSON file and kind of understanding here's the full set of resources I have. But these days, most of the folks I see working in the cloud space have hundreds or thousands or tens of thousands of resources that they're managing, both because of just the complexity of their applications going up, but also just the granularity of some of the building blocks they're working with going up. I mentioned that just using ECS to deploy a container, you're going to have 50 or so resources deployed in AWS just to do that. And so at that point, having hundreds of thousands of lines of JSON to look at is no longer really the reliable and best practice way to author anything. You're not going to really be able to get a clear understanding of the behavior of that piece of infrastructure by sitting there and reading 100,000 lines of JSON. And so you're going to have to find ways, just like we do with software engineering, to take pieces of that, give them clear names, give them clear interfaces, describe the contracts they have with the rest of the world, and then trust that the implementation of those has been tested and validated to meet that description, and now go and use that abstraction instead of the raw building blocks and copying and pasting everywhere. And so I sort of fundamentally think that for anyone working at a meaningful level of scale, and I think that everyone will be working at a meaningful level of scale with where the cloud is going, that the idea that it's going to be sustainable to just have giant JSON documents as the way we do this just doesn't resonate with me in terms of how I've seen kind of software engineering evolve over the last few decades.
And one of the common aspects of what you have built and what Terraform is doing is this maintenance of the state of the infrastructure as it's been provisioned by those given tools. And I'm wondering why that is seen as a desirable or a necessary aspect of the design of these tools for being able to maintain that statefulness, as opposed to relying on the state as it's represented through the APIs of the different cloud providers, so that it's able to be a little bit more dynamic or able to more easily incorporate existing infrastructure without having to control it all from day one.
Yeah, so I mean, the need to kind of maintain state is actually mostly rooted in just the cloud platforms themselves. Oftentimes, they don't actually provide access to all of the information that you need to create a resource. They don't necessarily give back all that information when you read the resource out of the cloud provider. And so because we have to be able to diff the desired states to be able to provide this sort of reliable infrastructure as code model, we need to know, here's what I specified previously, and here's what I'm specifying now, and here's how those things are different. And unfortunately, we can't go and ask the cloud provider, what did I specify as the inputs to this thing the last time I provisioned it? Because even though 80% of that is available, there is for many APIs and across all the different cloud providers, there is enough of that information that they do not provide back. That unfortunately, we do have to maintain a history of kind of what did we ask for the last time, and how is what we're asking for now going to differ from that, and what might change because of that. And so I think that's something where ideally the cloud providers would evolve to where their APIs did let you see what was the configuration that got used for every resource being managed last time. And this is something that, for things like CloudFormation, they take care of this kind of internally inside AWS, and so you don't see it as much. And it's why you kind of see it more in tools like Terraform or Pulumi, because it's managed outside of the cloud provider. But the same concept has to apply for those tools as well, where they have to track kind of what are the diffs in the inputs that were specified between different iterations of the deployment. And so it is something that Pulumi does need to do, is manage that state and understand kind of what you deployed the last time and what state things are in. I'd say one of the things that Pulumi does kind of differently is, by default, Pulumi stores that state in the Pulumi backend service itself. So, any user of Pulumi, when they get started, they don't really have to think about the state file at all. They don't have to think about managing it on their local machine or storing it themselves. It's just transparently handled by Pulumi. And then if they need to, for kind of compliance reasons or whatever, take ownership of that file and manage it themselves, they can do that. But we try to make that not something that developers really have to worry about initially when they get started.
And the maintenance of that state does add a bit of complexity and sort of upfront planning in terms of how developers think about how to structure their infrastructure code, because of the possibility of having such a large amount of state that is tightly coupled, and so needing to determine what are the dividing lines between different aspects of the infrastructure. I'm wondering if you can talk through some of the design considerations that they should be thinking of, and some of the useful practices that you've seen for ensuring that statefulness this doesn't end up being a liability instead of a benefit?
Yeah, so generally in terms of sort of, how folks we work with Pulumi sort of think about breaking up their infrastructure and things, I'd say for me, I often sort of analogize it to sort of the monoliths versus microservices kind of debate, kind of from a server application development perspective. And in some sense, it follows a lot of the same kind of lines of reasoning. So monoliths, in all cases, tend to be sort of easier to reason about up to a certain scale, and where we just have kind of one unit that's versioning cohesively and can sort of have boundaries within it we still have sort of software engineering practices in terms of we have good boundaries between APIs inside that monolith, but they don't have to be versioned boundaries that are backwards and forwards compatible and that kind of thing, because we're all versioning as a single unit. We're all, the team is all working in a single code base, that sort of thing. And so in some sense with Pulumi, it's easiest still to kind of keep things in one unit of deployment, as long as the team working on it is sort of working together, and as long as it makes sense to be deploying that in a single versioned unit. But as teams grow and evolve, and as the software being deployed grows and evolves, it often becomes valuable to split these things up into multiple units that have maybe different teams working on them, that are delivering and versioning at different cadences, and that are ultimately going to have boundaries between them that are well-defined interfaces that have they're much more sort of fixed in a sense. Those interfaces are things which have to have high levels of compatibility because they may intermix in various directions with other components, and they may not even 100% know all of their consumers, and so they have to have sort of very clean versioning guarantees around them. And so with Pulumi, we can do all those same things. We can break up our infrastructure into multiple pieces that are owned maybe by different teams, or that kind of are going to version at fundamentally different cadences, and we can define those contracts between those layers. So I can expose a set of infrastructure definitions from a lower level stack, for instance, and then consume that from a higher level stack, effectively define that API in between those two components. And so we see things like maybe the sort of core networking and security infrastructure is one stack that is owned by a platform team somewhere and that versions fairly slowly. And then there's potentially application related stacks that include specific things about how that application gets deployed into the compute infrastructure, or what the IAM roles and policies related to that specific application are, or maybe even some of the data stores that it might want to use, like maybe it uses a queue or a DynamoDB database or something like that are application specific, and those things are going to iterate more with the speed of the application delivery itself. And so can be owned by that different team, have that different cadence of delivery, but they may need to reference that lower level stack and understand, hey, what was the network that I want to run in, or what was the core security groups that I want to apply to run my compute within this environment. And so that's something that we support. And in general, I think people's intuitions from kind of the monolith versus microservices lines of thinking and how that applies into the way they build their services can apply very, very cleanly into their infrastructure as well.
Digging further into the specifics of Pulumi itself, can you describe a bit about how it's implemented and how the overall system is architected and some of the evolution that it's gone through since you first began working on it?
Yeah, definitely. So, the core of the tool is actually just a CLI tool, the Pulumi CLI. And that Pulumi CLI, there's sort of two deep things that it kind of wants to scale really well with. So one is with cloud platforms. So we support, AWS, Azure, GCP, Kubernetes, but also 50 or so other SaaS and cloud platforms. Like if you want to work with Cloudflare, or you want to manage users and databases in MySQL, or you want to, work with Okta. There's lots and lots of different cloud infrastructure you may want to interact with, and Pulumi has providers for all of those. And so there's a lot of different providers, and we want to make sure that we have kind of a nice plug-in model around how it's easy to build new providers and have those get consumed inside Pulumi. And the other direction is languages, of course. So Pulumi supports today Python, JavaScript, and with 2.0, which is launching again very soon, we're GAing our support for .NET and Go as well. And so we have a variety of different languages today. We're expecting that to keep growing over time. And so we want to make sure that Pulumi kind of scales well both on the cloud platforms and on the languages side. And so both of those, we have kind of a plugin model where that Pulumi CLI can know how to launch a language plugin. If the user's Pulumi application says it's a Node.js application, we'll go and launch a Node.js host to run their code, and then that host will communicate back to the engine what resources are being defined by that code in a language agnostic way. And then the engine will figure out what the previous state of that was, how that differs from the current state. And if it wasn't there in the previous state, we'll go and ask the cloud provider to create it. If it was there, we'll ask the cloud provider to update it. And so the Pulumi CLI effectively just does this sort of orchestration job in between languages, which actually run the user code, and cloud provider resource providers, which know how to provision, create, read, update, and delete resources inside the cloud providers. And so the architecture of Pulumi is really an engine which sits in the middle, and then a bunch of different language hosts for each of these different language ecosystems, and then a whole bunch of cloud providers for each of these different cloud provider ecosystems.
And I know that another element of the Pulumi ecosystem that is more focused on the business side of it is the managed platform that you provide for hosting the statefulness of those different deployments and also handling some of the collaboration capabilities. So I'm wondering if you can talk a bit more about how that fits into the overall lifecycle of working with Pulumi and some of the ways that you're approaching the business model to ensure that this is a sustainable project.
Yes, I mean, one key thing actually to note is that the Pulumi SaaS, so app.pulumi.com is our console that basically provides users access to all the different deployments they've done, the history of kind of what resources have been under management, links into the cloud providers, a whole bunch of capabilities to, as well as sort of driving your deployments from the CLI to actually understand the state of the infrastructure that you're managing. And that's available. There's a free tier of that, so everyone who uses Pulumi has access to those capabilities. But like you said, it's also part of, kind of where we offer paid offerings as well for teams and enterprises. And so, we see a lot of teams who go and use Pulumi to deploy their infrastructure. At the point where they're sort of taking that into production, they kind of find that they want to be able to have a team of folks collaborate on some infrastructure, and they want to bring some more controls into that environment. So they want role-based access control for the different users within their team and what access those users should have. They want the ability to sort of automate things around the service, so webhooks and REST APIs and that sort of thing. And ultimately for enterprises, they want the ability to enforce policy organizationally across everything they're doing. And so those paid offerings in the service side really focus on helping teams and enterprises to apply Pulumi at scale. We really try to make sure that all sort of core capabilities of Pulumi are available as part of the open source project and as part of that free tier, including the backend service. But really the things in those paid offerings are about enabling organizations at scale to really apply Pulumi successfully as they apply it across different parts of their team.
And given the fact that you have this many-to-many engine in terms of mapping the different languages to the different providers, I'm wondering how you approach maintenance and feature parity across those different languages and ensuring that the providers are properly tested and validated to ensure that there aren't any surprises for people who are trying to use it.
Yes, I mean, this is, I think, one of the interesting kind of core challenges of kind of what we do with Pulumi is that, and I think we really do lean on the ability to sort of auto-generate and drive off of sort of schematized models, both from the cloud providers and even within our language SDKs, so that we can sort of build, instead of M times N, we can build like M plus N, right? Things and validate those and make sure that they work really reliably. And so we've put a lot of investment into sort of the tool chain that we use internally around doing that, around making sure it's easy for us to light things up for all languages at once. So when a capability comes in a cloud provider, for example, that automatically gets lit up across every language that Pulumi supports. And making sure that, as we add new capabilities into the core platform, into the core Pulumi programming model, that we have a sort of consistent approach to how we do that across all the different languages that respects the ways in which the languages are different and the programming models of the different languages are different, but still is able to express all the same sort of core concepts that we want to in the Pulumi programming model, so that it's easy for us to add in new capabilities into all those different programming models in a natural way. And so that's sort of a key API design challenge. And luckily, we've got a handful of folks on the team who have spent, a good amount of time in their careers working on API design in a lot of different environments. And so doing that here with Pulumi is sort of a fun challenge just because of the sort of two-dimensional matrix here.
And you mentioned the fact that you're working to maintain some of the idiomatic principles of the different languages rather than just sort of spitting out a bunch of auto-generated code for these different providers. I'm wondering how you are managing the sort of mapping of what those idioms are in the different languages to just the base schema that's actually driving a lot of this logic.
Yeah, so I think, some of it was just for each one of these languages, before we bring up the language in the first place, we go pretty deep on experimenting with a lot of different API designs and how we could embed the sort of core Pulumi model into that language in a way which would feel really natural for users of that programming language, but would also sort of faithfully and in a way which is going to work well with Pulumi, let people express what they want to. And so I'd say that, for each new language we bring up, that's a big part of what we have to do, is really spend the time kind of thinking about what it looks like to do Pulumi in that language in a really natural way. And so I'd say that is an important thing. Once we kind of come up with a core model, then we just need to make sure as we evolve that core kind of Pulumi programming model that we do so in a way which kind of respects the constraints that apply in each of these different languages. And that part we've generally found to be a bit easier. But there is some work to do to kind of find an API design that's going to fit well in the first place in each of these language ecosystems.
And one of the main tests of the viability of any tool is how much the community rallies around it and how much community contribution there is to build out an ecosystem for that particular tool or platform. And one of the big successes of Terraform is that it has grown that community. And so there are a large variety of different providers for different platforms. So I'm curious how you're approaching the bootstrapping process of building out the ecosystem for Pulumi and some of the challenges that you're facing in terms of being able to build out some of that broad support that will help to create a useful feedback cycle to bring more people in to continue growing that ecosystem.
Yeah, so I think one of the key things is, Pulumi is also open source, and so pretty much everything we've talked about here today is kind of open source components. So we've seen a lot of folks jump into that ecosystem just in the various different open source projects, make contributions, everything from small things to significant feature capabilities. And of course, by setting up that sort of kind of core open source of the projects that we contribute to, also seeing a lot of other projects pop up around Pulumi to sort of apply Pulumi in interesting ways. So some test frameworks, some higher level libraries, various different open source projects built by folks in the broader ecosystem to enable people to take Pulumi kind of even further. And so we do very much believe in kind of doing things in the core to empower and enable folks in that ecosystem to kind of expand what they do. And we've seen huge growth there. I think we've seen massive growth in just the usage and in the sort of contributions and ecosystem over the last year or so. And so we're seeing great growth there. Of course, some of these other ecosystems have been around. Terraform has an ecosystem that's been around for a while, and so there's a ton of great value there and a really nice ecosystem. And so one of the things we do there is, we say, hey, because there is such a great ecosystem around the Terraform providers in particular, we let folks kind of use those Terraform providers as well if they want to. So the Terraform providers, you can wrap those in kind of a Pulumi API and now get that from your Python or your JavaScript code. And so we don't want to just compete head on with the kind of Terraform resource provider ecosystem. There's a great open source ecosystem there. We want to actually let folks take advantage of all the value being built in ecosystems like that from Pulumi as well.
And in terms of the actual workflow of working with Pulumi to build and maintain infrastructure, what's the overall process and life cycle of the code and how it fits into the development cycle?
Yeah, so I think we see, folks when they get started with Pulumi, they, download the Pulumi CLI and they, run Pulumi up to deploy some infrastructure that they've authored locally on their machine. And so I think then they'll kind of iterate for a little while, making changes to that infrastructure, deploying it into their environment as they're sort of doing development of a new piece of infrastructure. And then at some point they'll decide that that's ready to kind of be something which deploys into a staging environment or production, and they want to have a reliable way to deploy that. And so typically move that into a CI/CD pipeline. And so they'll move from running that Pulumi up, locally on their machine to running that Pulumi up inside a continuous delivery environment. And so Pulumi plugs well into sort of any kind of CI/CD setup you have. We have kind of documented guides for doing that with 10 or so of the most popular tools out there. But basically now, once you've moved there, now you're going to do something like either a Git push or some other kind of workflow that where you push new code into some particular branch, that's going to trigger a deployment into a corresponding environment, whether that's a staging environment or your production environment or what have you. And so once folks move in that kind of model, now they're sort of doing proper kind of GitOps or CI/CD around their deployment. But they still may want to actually, as they're building up a new capability on that feature, they may want to spin up a dev environment, for example. And one of the things that Pulumi makes really, really nice is in a sense that it becomes easy to spin up a whole nother copy of your infrastructure or of some subset of infrastructure to iterate quickly on potential changes you might want to make to that. And so you might spin up a new stack that's for your development environment locally on your machine and make changes locally, verify those, see if it's doing what you want, and then open up a pull request or whatever to contribute those changes back into the shared staging environment, for example. And so we see a lot of different kind of workflows around that core idea, but in general, there's that combination of using Pulumi as a deployment tool locally on your machine while you're iterating and developing capabilities, and using it in CI/CD for delivery into fixed, consistent infrastructure that exists over a period of time.
And as far as the testing of infrastructure, what are some of the useful practices and patterns for being able to do some of that validation without necessarily having to deploy and destroy full stacks of infrastructure?
Yeah, so we really see kind of three patterns that, we've worked with a lot of teams. I think when we talk about Pulumi to different teams, when we talk about bringing software engineering practices into infrastructure, I'd say one of the first things that comes to people's mind is, so does this mean I can test my infrastructure? And today, the first approximation, nobody doing infrastructure is really testing it. And there's this sort of big hole, and a lot of organizations feel are concerned about the fact that they're not validating their infrastructure earlier. And so the idea that, hey, can we bring a lot of these testing capabilities that we're used to using for our application delivery, can we bring those into our infrastructure? This is sort of one of the first things that comes to people's minds. And so we kind of see three patterns of how we can apply that with Pulumi. And the first is just unit testing in sort of the traditional sense, which is writing tests that kind of validate individual pieces of your infrastructure, but without having to deploy it. So we can validate that if I provide these inputs to this component, it will create these resources with these configurations. And so it's more about the correctness of the logic of my program than of the ultimate desired state of my program. And so this is something that helps us tame some of that as we're increasing that complexity and moving away from a declarative way of authoring and authoring using some of these richer programming model constructs. We can validate the correctness of that logic using unit tests. And so this is the first thing that the teams reach for, and is really kind of fundamentally something that Pulumi enables that's kind of hard to do if you're not using existing programming languages. And of course, we can plug that into any programming language's testing ecosystem. So you can go and use the integrated Python testing frameworks, Python unit tests, to test your infrastructure using this. And again, that model doesn't actually deploy any resources to your cloud. It just tests the logic of your code is correct. The second one is sort of validating invariants that you want to be true. And so I talked kind of earlier about some of the policy enforcement we have. And some of that policy enforcement can also be used to validate just correctness, in a sense, of the infrastructure. So when you do end up actually going and deploying infrastructure into a cloud, immediately before we actually deploy something, run some validation that we didn't violate an invariant, like we didn't open up a port that shouldn't be opened, or we didn't deploy that image that shouldn't be deployed. And so we can run that kind of testing, which is sort of testing that will catch just before we deploy it, make sure that we didn't do anything to violate an invariant. And then the last is actually deploying whole copies of my infrastructure and really doing, I think we think of it as sort of integration testing. And this one is actually really valuable. I mean, ultimately, a lot of what you want to test related to infrastructure is fundamentally about the behavior of the cloud provider and whether you've wired things up correctly to get the behavior you want out of the cloud provider. And so a lot of the validation that we might want to do of our infrastructure really does rely on spinning up the infrastructure. And so for that, Pulumi provides some test frameworks and things which let you take some infrastructure you have, stand up a copy of it, run some validation against that to make sure it's behaving correctly, and then tear it down, and to do that sort of ephemeral environment testing. And one of the things we found there as well is that that approach generally is valuable, but it's particularly valuable when you do this sort of software engineering idea of building reusable components, because now I can build that reusable component with that well-defined interface, and I can write a bunch of tests that sort of test the parameterization of that interface. And so if I have an abstraction that makes it really easy to work with containers on AWS, I can sort of say, well, here's all the different ways I can parameterize that. I'm going to write a set of tests which try out, a bunch of different points in that spectrum and stand up copies, validate that it works, and tear it down. And so I can run, 100 of these tests in parallel. I can run those in a couple of minutes. The total cost of running that is cents. because it's only the infrastructure is only up for a couple of minutes. And I can validate that that component does what it says it does, even to the extent of validating the correctness against the cloud provider. And so this kind of testing we find is really valuable and really kind of ties back into that idea of building reusable components and software.
And then as far as the infrastructure as code space itself, what are some of the limitations of it in terms of being able to actually get fully working sets of applications up and running? And where do things like configuration management tools fit into this overall landscape? And what are some of the options for integrating them with Pulumi for things like SaltStack or Ansible?
Yeah, so I think, kind of addressing the second part of that question first, and then I'll get into the first part. I'd say, today, Pulumi can work with sort of the wide variety of different kind of compute primitives out there, everything from kind of VMs to containers to serverless, what have you, and also combine those all really well. And I think in particular for folks working with kind of VM-based cloud deployments, that's where they're sort of looking at some of these configuration management tools to sort of do the ingest provisioning and to be able to consistently apply kind of that same infrastructure as code model, but to the things that need to run inside their VMs. I'd say when we look at the sort of containers and we look at serverless, some of it gets a bit inverted because we don't tend to use configuration management tools as much anymore once we're using Docker or serverless. And instead, sort of the cloud provisioning model that Pulumi tends to manage is actually the thing that contains that specification. So my Kubernetes deployment and my Kubernetes service effectively are my configuration management, and that's something that I'm going to define kind of using Pulumi. And so as we move to some of these more modern kind of cloud compute technologies, we find that a lot of the sort of work the infrastructure as code work to manage that stuff is actually moving out of some of these configuration management tools and into the cloud infrastructure as code tools like Pulumi. But for folks who are working with VMs, can certainly mix and match tools. And so at that VM boundary, you can sort of do whatever you want. So kind of have the ability to connect user data and those sorts of things to bootstrap VMs and bootstrap into something like a SaltStack or what have you. And higher level integrations, like we have this concept of sort of dynamic providers where you can provide custom providers effectively inside the Pulumi model that can do things like SSH into a VM and run some bootstrap scripts or whatever. And so lots of different ways to bridge between these two worlds. But we also see that generally a lot more of this workload is directionally moving into the cloud infrastructure code tools and kind of modern infrastructure code tools like Pulumi.
And what are some of the most interesting or innovative or unexpected design patterns or integrations into the broader Python ecosystem that you have seen your users use with Pulumi in their infrastructure projects?
Yes, I've seen a ton of really interesting things. One is, I think one pattern we've seen a ton of is actually folks moving towards managed cloud, so using AWS or Azure or GCP, but also using Kubernetes. And so that combination of getting the best of sort of managed services that are available inside these cloud platforms and getting the operational benefits of those, including of the sort of managed Kubernetes clusters, but then being able to use sort of the standards-based API that Kubernetes provides over compute and just the richness of that API. And Pulumi sort of really makes it uniquely easy to work with that combination of things and to take advantage of the best of both managed cloud and Kubernetes. And so I've seen a lot of folks doing really interesting things, combining those two, using those to kind of get the best of both worlds for managed services and Kubernetes. Other things I think we've seen that are really interesting. One pattern that I am kind of excited about is a shift from infrastructure as code just as a tool for a human in the loop kind of tool where a user is going to make a discrete change and validate that change and deploy it, to a model where we're actually building software systems that drive these deployment processes as well. And so we work with a lot of companies and teams that are actually provisioning tenants, for example, in their backend for their customers or for internal teams within the organization. And they're doing that through automated processes. It's not like a human is going and saying, oh, I'm going to go and provision this tenant or update this tenant. They actually have automation that's driving a lot of that. And so that requires a much more reliable tool chain around how we do these infrastructure deployments to be able to do that. But we're seeing that as software engineers are taking over and as the complexity is becoming higher here, and they're really looking as well for how do I turn this from a human process into a automated process at even another level. And so Pulumi is fitting really well into those kind of patterns, and I've been excited to see some of the successes we've seen there.
What are the cases when Pulumi is the wrong choice and somebody might be better served by either a different infrastructure as code tool or just avoiding that overall approach and design pattern in general?
Yeah, so I think, Pulumi does try to make a lot of things easier, but I'd say, if you only have a small number of resources, or if you're just managing a VM and you're primarily going to be doing, Salt Stack or Chef or Puppet or something for your provisioning, Pulumi could well be overkill, right? You might not need to sort of do some of the taming of complexity. You might not need to bring some of these software engineering practices. You might honestly be fine pointing and clicking in a console for a small number of resources. Or if you're using if you're going to be using Elastic Beanstalk, for example, and you just want to click a button to kind of stand up your Beanstalk instance, and now you're going to work with their customized tooling for their platform as a service offering. You may not need Pulumi to stand that up. The incremental value around that may not be as significant. But we see as folks sort of the complexity of their cloud infrastructure goes beyond tens of resources, they're almost always going to be looking for some subset of the things that Pulumi kind of brings and helps with. And so we think kind of as they hit a certain level of kind of cloud complexity, they're gonna be looking for tools like Pulumi inevitably.
What do you have planned for the future of the Pulumi toolchain and the business itself?
Yes, I mean, we're really just getting started still. I mean, the company's been around for a few years and we've been growing really quickly, but we still see an enormous amount of opportunity around the core Pulumi toolchain and also around expanding from sort of just the core kind of infrastructure as code tooling to provide software engineering focused tools for more of the cloud engineering jobs. And so we have a lot more we expect to do over the coming years, but we're really excited right now to just continue to be growing how people are doing software engineering for cloud infrastructure. And yeah, I think there's a lot of specific things there. I think, we're continuing to support more cloud platforms, continuing to support more languages, continuing to support more richness in the kind of high-level libraries that we expose to users so they can more easily work with a lot of these newer and more complex modern technologies. And ultimately just making it more fun and easy to deploy infrastructure, making it something that developers are going to love working with instead of something they're going to fear working with. And so we put a lot of effort into just making the CLI user experience nice, making the documentation nice, these sorts of things to make sure that infrastructure can be a kind of lovable thing for developers.
Are there any other aspects of Pulumi itself or infrastructure as code in general, or the benefits and integrations of using full programming languages with this space that we didn't discuss that you'd like to cover before we close out the show? Yeah, I mean, I think there's so many fun topics in here. One thing that we kind of didn't discuss that I think is sort of an interesting thing as we move forward is also kind of the way that the infrastructure deployments and the application deployments end up getting potentially merged together. Today, most teams really think about their infrastructure deployments and their application deployments as being two totally different sort of trains. When they make updates to their infrastructure, they deploy those through one CI pipeline, and when they make updates to their applications, they deliver those through another CI pipeline. And one of the things we're seeing increasingly is, especially again around serverless and containers and Kubernetes, that there's a lot of different ways in which the application code and the infrastructure it runs on are getting more and more tightly kind of coupled. There's dependencies on a managed queuing service or a managed database or a managed Dynamo table or a managed cache. The application code really wants to tightly couple into its versioning. And so we actually see a lot of interesting things happening around how those two are getting merged, and the application delivery and the infrastructure delivery are kind of moving into a single unit in some places. And I think that's a really interesting trend. It's something that Pulumi is kind of is being used for quite a lot relative to kind of where that trend is in the industry, but I'm kind of excited to see where that trend goes as well. Well, for anybody who wants to follow along with you or get in touch or get involved with the project, I'll have you add your preferred contact information to the show notes. And so with that, I'll move us into the picks. And this week, I'm going to choose an app that I found for being able to catalog the different books that I have, because it's something that I've had in mind for a while. And now that I'm spending a lot more time at home, I'm starting to get involved with that. And it's just makes it very easy to be able to scan the ISBN code of your books and add it to your virtual bookshelf so you can keep track of what you've got and categorize them. So I'll add a link to that in the show notes. It's just called Bookshelf. And so with that, I'll pass it to you, Luke. Do you have any picks this week?
Yeah, give a kind of a random one. It's something I was looking at over the weekend that I thought was really neat. Just a little service called GoBinaries.com, and we at Pulumi work a bit with Go. That's sort of the language we use for building our CLI and that sort of thing. And so Go Binaries is just a little tool built by TJ Holowaychuk that lets you just serve Go binaries from a simple HTTP endpoint. And so instead of you having to build installers and that sort of thing as somebody building little applications or services, you can just point folks at Go binaries and they'll do the build for the user's platform and deliver it. And just a really beautiful, simple little service. I think it's a fun thing to go look at the code if folks are interested in kind of seeing a little bit of Go code or a little service. And just a kind of fun, nice little piece of software that he built. And actually over the weekend, I kind of played with kind of re-implementing that just as a pure Pulumi thing, just to kind of play with some ideas there. And I think it's just a neat little example to look at.
Well, thank you very much for taking the time today to join me and discuss your experience of building Pulumi and working in the infrastructure as code space. It's definitely something that is very challenging and complex and something that a lot more people are having to get involved with. So it's great to see more projects coming into the space. So I appreciate all your time and effort on that, and I hope you enjoy the rest of your day.
Likewise. Thank you very much for having me.
Thank you for listening. Don't forget to check out our other show, the Data Engineering Podcast, at dataengineeringpodcast.com for the latest on modern data management. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts@podcastinit.com with your story. To help other people find the show, please leave a review on iTunes and tell your friends and coworkers.